G'day there. You're watching the Aussie BIM Guru, and today we're entering our second lesson in C Sharp. Now, in this case, it's mostly going to be focused around C Sharp fundamentals, not really Revit in this case, but it's an introduction to variables and computation, which I think is important to clarify, even if you've used Python or a similar variable-based language before. So the goal today is to introduce you to some fundamentals about variables, declaring, assigning, and managing them in an object-oriented programming environment, specifically C Sharp. And by the end of the tutorial, you should have a better understanding of how we're going to be managing them in the tutorials where we're actually using Visual Studio. So today, this is very much just a theory-based lesson, but I think it's a very important one to clarify so that you understand the concepts we're using later on. Now, this might be very simple if you've already used quite a lot of Python or if you've used any other object-oriented programming, but some of this will be very fundamental to how you use variables specifically in C Sharp. So I do recommend at least skimming through this video, even if you think you're familiar with these concepts. Some things are different in C Sharp. Now before this, I want to actually just briefly summate how memory and computation works behind the scenes. Whilst you won't really use it that much, especially as a beginner in C Sharp, I think it's really important to understand behind the scenes how memory is being managed. And eventually, when you get further into using C Sharp and programming, you may actually return to this concept at a more important level where you might want to manage your memory more effectively. So Programming 101. Now, a lot of this I learned through the Harvard CS50 course. I do recommend checking it out if you're interested. This is a very high-level overview. So to understand memory, we need to understand binary language. In this case, let's look at a light bulb or a light switch, and let's say this light bulb is off. We're going to say that in this case, it is false that the light bulb's on, it's off, and let's call that condition 0 or off. Now let's turn the light bulb on. Let's call this 1 or true. So we've got an object here that can store two conditions, 1 or 0. If you're looking at quantum computing, you might be able to look at this as a dimmer switch with a wide range of options and a probability of how on or off it might be. Let's add another light bulb to the left, importantly to the left. In this case, we can now represent two states, two bulbs, and in this case, we can have a 0 and a 1, or a 1 and a 0 and a 0. But what does that mean? Well, now we need to introduce a mathematical concept. I know math's all scary. We're going to use what's called a base 2 numbering system. So we say that the bulb furthest to the right is 2 to the power of 0, or in this case 1, and then 2 to the power of 1, which is 2, 2 to the power of 2, which is 4, 8, 16, etc. And then we multiply them by whether they're on or off. Now this system will actually let us sequentially create any range of numbers with an upper limit. So in this case, we can see we have 5 in this case. So once we have 8 of these bulbs, we can go all the way up to a state that represents 2 to the power of 7, which I believe is 128 off the top of my head. Let's call all of these bulbs bits, and let's put 8 of them together and call that a byte. So memory is broken up and addressed as bytes, or 8 bits at a time. We then create a table, and this happened a long time ago in the foundation of computation, that represents what these byte values can mean. In this case, this is called the ASCII table, and it helps us actually represent a wide range of characters and conditions at a very raw computational level. So for example, we can see the ASCII for 48 is in this case, the number is 9. So we can see that if we represent that in a binary sense, excluding zeros to the left for convenience's sake, we end up with 16 plus 32, which is 48. So we can actually represent a wide range of characters, in this case 128 of them in this range, and of course by adding additional bytes in, we can go beyond this to represent things like emojis and foreign characters. As well as this, in computation, a really important principle behind the scenes is called pointers. And you may come across this in error messages sometimes. Effectively, a pointer is pointing to an address in a computer's memory using what's called a hexadecimal-based address. Now, you don't need to understand any of this technically. I just think it's valuable to be aware of it. Now, if you're not writing in C Sharp, you're just writing in C, part of this is actually you having to manage pointers in memory and checking memory in or allocating it, and also deallocating it and giving it back to the computer when you're done with it. The really good news about using C# is that there's a special object or class here called the garbage collector, and its job is to basically get rid of memory you're no longer using and give it back to the computer to efficiently make use of memory and ensure that you never exceed the amount of memory you have in a core at a given time that you're accessing. So the good news is you're not going to have to allocate and deallocate or even use pointers technically, but just be aware that they are a really important concept foundationally behind the scenes. Pointers and what we call structs in C, which are special classes that can hold a few pieces of information together, actually allow us to connect objects together into what we call linked lists. On the surface, you'll understand this concept as lists. Behind the scenes, they're more commonly called linked lists, and this is effectively a special way to store and chain data together. And it's a principle we use in C# a lot, but we don't have to worry about using structs and pointers and all the behind the scenes stuff that's actually holding all these objects together in a sequence. So why does it even matter? Well, eventually, like I said, you might want to come back to this when you're actually trying to manage memory more effectively and make your code faster and more optimal. Chances are you may never need to, depending how complex you want to write code to. And I guess the main takeaway here is behind the scenes, you're constantly managing memory when you're working with C#, even if a lot of it is done for you. And the main takeaway here is that we're constantly communicating with C# or the compiler and telling it what type of data we want to use, which is very different to writing in something like Python, where you generally don't have to. So let's look at very fundamental types of data. Again, very fundamental, you might be familiar with some of this, but let's begin with the Boolean, true, false, on, off, 1, 0. Unlike Python, the main thing to note here is when you're writing Booleans, you'll generally use lowercase instead of uppercase for the prefix. Integer, in this case a very specific type of integer, int as we call it in C#, is a whole number with no decimals, and by default it's a signed integer. So that means it can be positive or negative, so effectively half of the potential of the memory being used for this integer is actually supporting a negative, and a positive scenario, I believe in this case there's a sign bit that's involved with it as well. Now you can use different types of integers. There are 32-bit, 64-bit, and they effectively just hold more information. In this case, by default, integers I believe are 32-bit based. Double effectively supports a floating point, but it isn't in itself a float. It's effectively twice as big as a float. So a double has 64 bits and a float, which we don't use as often these days, has 32 bits. From a legacy perspective, we began with float, I believe, and then double was created to store more information. Generally in Revit, when you're dealing with decimals, you'll mostly be dealing with doubles in most cases. Chars or characters, again, are probably something you're not so familiar with if you've used Python, because we don't generally use characters. We use a single string with a character in it. But in this case, A, B, C, declared with a single apostrophe, either side represents a character. So characters can only, as the name implies, store one character, which is effectively anything from the ASCII table. In this case, 9 is technically a character in ASCII tables as well, so you can store numbers in the form of characters. They generally use 1 byte or 8 bits. But we can abstract the concept of a character or a character array into a string, and now something you might be more familiar with in Python. So strings, technically, I don't believe are a class in themselves in the base of C, but you create an abstracted concept out of them, which luckily C# does for us. Strings are an array of characters, so a consecutive sequence of characters in memory, which is, again, like I said, abstracted. It's simplified for us into a class that basically behaves as if we're writing a character as a string. You might occasionally hear them called char stars. That's more like a nickname that people give to them in C, given that's how they're often declared in the C language. Null is a very important thing to familiarize yourself with. You'll be taking advantage of it a lot. It effectively represents an absence of data, and it's effectively a pointer to, I believe, the first byte in memory, which indicates to the compiler, to the program, there is no data. And often that means maybe something's went wrong, or maybe you're taking advantage of this special type of object to make sure that you can process logic in a particular way. Null is generally written as null, And you will be looking and checking for it quite often, especially when working with the Revit API, which has a tendency to return null when things don't quite go as they should, which will happen in the Revit API quite often. Some data types are nullable, which means that they can be set to null. Not every data type in C# can be set to null unless you tell it to be. For example, integers aren't nullable naturally. You have to actually tell them with a modifier that they're actually nullable. Now we'll come back to this later when we're looking at passing data between types, which is really important when you might be passing data that might not convert naturally to another type. There might be errors. But in this case, you're not generally going to have to worry about this because most Revit API classes will be nullable by default. There's another type of structure in C# called arrays. Now you might come across them occasionally in the Revit API, but for the most part, you're mostly going to be using lists to manage your objects. So be aware of arrays, understand the difference between them, and the core difference between arrays and lists is that arrays occur in sequence in memory. So they have to occur with a set number of objects because there might not be room on the back end to expand them. And as well as this, you're also going to have the difference that lists can obviously expand and change in size because they're basically just being linked between pointers to different places in memory. So in this case, if you declare an array of objects, generally you're going to declare the size of the array when you do it, which is often not going to be very suitable for how we want to manage objects in Revit because we might gain or lose objects in a list instead. Compiling is a really important term to understand. So typically C# code will be faster to execute because it is compiled before execution. Generally this means we're turning our human-friendly written code into computer-friendly machine code, ones and zeros, written in a byte structure to be ran in the program. So when we build our solution in C#, it's effectively compiling it into files that are ready in machine code to be consumed by an application. So in this case, we create often dynamic linked libraries or DLL files, as you probably know them, to be executed by Revit in the add-in. So languages like Python instead use an interpretive basis to work. So in this case, we're going to just briefly look at declaring variables and how that typically looks in C#. Now I could do this in Visual Studio, but I figured it's just easier to theoretically talk about it first and then apply this in a few lessons time in C# with the basic understanding gained from this lesson. So in this case, if you want to declare a variable, you can use what are called access modifiers. We're not really going to touch on them for now. I don't want to overcomplicate this, but be aware that there are modifiers that you might see on the front of a variable declaration sometimes, such as public, static, private, internal, virtual. We're going to come to these later. The most important thing I want to emphasize here is that unlike Python, you're generally going to have to declare a type that you're assigning to the variable when you initialize this variable. For example, int. So this will tell the compiler and Visual Studio what type of object it should be anticipating or storing, which will also relate to how much memory it needs to use to store that object. After the type, you're going to need to give this variable a name, which is something you'll be more familiar with if you've used Python. You'll generally want to give this a fairly good name, so you don't want to use words that often are used by the program. For example, I wouldn't call a variable int because that word is pretty much already used by a type and will confuse the program and the compiler and generally won't be allowed in Visual Studio. It will generate an error. So a very good convention I use is generally camel case or sometimes Pascal case, but I generally prefer camel case, so first letter lowercase, at least 2 words, second word generally uppercased. We will come back to access modifiers later when we learn about classes, but for now, it's just something to be aware of. So this will tell the compiler what type it's using. Beyond this, we can also assign a value to this variable. So you can assign the value in 2 ways. You can assign it upon initialization of the variable by using an equal sign, and note that there's the semicolon on the end as well, which tells the line that's the end of the line. And we can assign the value, but it has to be a valid value to be assigned. So in this case, we can also assign it later. We just have to tell our compiler we want to create a variable, and later on we can give this variable a value. Because it knows what type the variable is, it knows how much memory it's going to need, it can reserve it in memory, and it can be assigned later. It's important to be aware that when you're declaring on the right, you're going to have to give it a valid value for its type. So let's say we're assigning an integer. So in this case, 5 is a valid integer representation. It will work. But if we assign something that's not valid, it's generally going to cause an error and we'll need to fix this. For example, 3.5 is not a valid integer, it's a double effectively. Or a string is not assignable to an integer, so it should be an integer. And we'll generally get told this by Visual Studio and have to fix this as we go. You can also create lists, and we're going to do a lot of this later. This is really just an example if you're curious how to create a list in C#. So you can declare the list just as a new list with nothing in it and add things to it later or set it to a different list. Or you can initialize it with objects stored, in this case, between curly braces. Generally, we're going to learn about these braces later as well when we look at what's called encapsulation. But we can see that just if we include curly braces with valid objects after, we will initialize a list containing these objects. But we will return to this concept later because it really is quite important to focus on in itself. A really important word when declaring a variable is var. So in this case, this is a variable. It can vary in type. So in principle, when we declare something with var on the left, we have to give it something explicit on the right that will tell the compiler this is the type of variable we want to store. If I'm creating an integer list, it's actually quite redundant to say integer list equals new integer list. If we say var list equals new integer list, instead we're telling already the computer this is an integer list. So instead we've already saved a bit of space, made our code a bit more readable, and this is generally best practice when you can get away with it. It's important to note that you shouldn't use var in a scenario where the type of the object could be ambiguous. It could be one of a few things, and this becomes more important when we start to look at what's called class inheritance. We're very briefly going to explain inheritance, but it's a more complicated topic. As well as this, you can take advantage of object type. So object is a special type that can be used when you want to store things into a more generic type of data that isn't necessarily going to be an integer, a string, a double. It's a more ambiguous type of data. Whilst something is an object, you often can't do a lot of things with it, but it can be useful when you just want to hold things, pass them around, move them through various functions, take them out the other side and convert them back to the type that you started with. This is going to be used a lot more later when we're working with forms, where we want to pass objects in and take objects out of a form that we just ran. So just be aware that is also a type. We're very briefly going to look at inheritance. So the Revit API is quite unique in that it uses a lot of class inheritance, which is both good and bad, but generally we'll take advantage of it. So metaphorically, let's look at how inheritance works. In principle, it means something belongs to a more overarching class that can also relate to other classes or types. So let's look at animals, for example. A dog is an animal, a cat is an animal. Dogs aren't cats and cats aren't dogs, but they're both animals. They both inherit the type of animal. Let's look at this in the Revit API. Two classes are views and floors. They both inherit the element class. Views are not floors, floors are not views, but they are both elements. Elements, or the element class, allows an element ID property. So views inherit this property from the element class, and so do floors. So we can interrogate both of these object types as elements by getting their ID. Floors have a slab shape editor. Elements don't, and views don't, because this isn't inherited from the element class, it's part of the floor class instead. And we're going to look at this later when we look at casting and typecasting, but for now that's just a very basic introduction to inheritance. Later on, we'll also be looking at checking types in order to know when we can do certain things logically. So if you want to declare that something is a type in, say, a logic statement, you can also assign a temporary variable to this and use it inside that statement. And we'll come back to this when we look at if statements. But it's just important to note that the is keyword is one way of checking if something is of a particular type. Now let's say this object is a floor that we're checking. So we can check if this object is a floor, but we can also check if this object is an element. You can check for inherited classes in the same manner. without having to change it to that class to check, which can be very useful when you might not be sure if everything you're dealing with is an element, for example, a null. So in this case, just be aware of this as a basic syntax for later. So this was just a very basic introduction, but I think a very important one that really helps me understand C# as well. So we have a very basic understanding of memory and computation, basic variable types and how we can declare and assign them, and also just a very basic introduction to inheritance. And we're going to be applying these concepts in a few lessons time, and it's just easier to sort of learn them here versus in the lesson on the fly when we're working. So in the next lesson, we're probably going to look at statements. It'll be a similar structured lesson to this one where we don't really use C# as much, but after that, we're going to be diving in and actually starting to use it. So if you're keen to see an example of these concepts in practice, feel free to check out my actual C# toolbar on GitHub, gWhiz, where I use variables a lot. If you like what you see, feel free to like, comment, subscribe, and share, and you can reach me at the email below. I know this was more of a theory/lecture-based lesson, but I figured it's probably important to get these concepts covered before we really dive into a practical use of C#. So I look forward to seeing you in future videos, and thanks. Take care. Bye.